Hi, welcome back to McClatchy Maths. My name is Natalie McClatchy and today we are continuing our video series on trigonometry by looking at exact values. And in this video you're going to find how to derive the exact values for cosine, sine and tan for the degrees 0, 30 degrees, 45 degrees, 60 degrees and 90 degrees using a diagram. And then we're going to do a worked example. Stay tuned for our next video too. This is going to give you a memory tool. And this video is aimed at students in grade 10 doing extension mathematics or prep math methods. And it's useful for students moving into year 11 and 12. So let's firstly talk about how we can build a table of exact values for sine, cosine and tangent. And what I mean by exact values is I'm not using my calculator. I'm using whole numbers that I derive as well as surds. So you would have covered surds potentially in grade 10 as well. So surds are irrational numbers and we represent those as a whole number underneath a square root sign. So we're going to actually fill out this table together using a couple of geometric diagrams. Okay, so we can get some exact values for 0 and 90 degrees because these are angles that don't really make sense in a right angled triangle. If you think about those, it wouldn't be a triangle if there was an angle of 0. We've got 90 degree angles as well, but we don't usually use trigonometry to work those out. So let's use our calculators. For sine 0, we're going to get 0 as a value. For cosine of 0, we'll get a 1. And for the tangent of 0, we'll get a 0 as well. These are important things to remember. So you'll notice that sine and cosine is the only one that's a 1 there. Let's have a look at 90. Well, sine swaps to a 1 and cosine swaps to a 0. So that's a good way to remember that the two of those swap. And the tangent, you'll notice you'll get an error or a syntax error on your calculator. That means it's undefined. Now what this means is that it's something divided by 0. And you'll find when you actually go to graph these, and we'll do that in future videos, that it actually doesn't pass, the tangent graph doesn't pass through 0 at all. So that's why there is no result. Okay, so now we're going to use some trigonometry to derive these remaining angles. So let's consider a right angled triangle here. I've got my diagram and we're going to have one of our short sides is going to be 1 unit long and the hypotenuse is going to be 2 units in length. So we're actually going to use trigonometry to work out the angles inside the triangle and also Pythagoras' theorem to work out the length of the other remaining side. Okay, so basically, if you're in an exam and you can't remember the exact values, this is a way that you can pull it together. Just remember hypotenuse 2, and then one of the sides is a 1. Okay, so that's that side B. We don't know its length. We're going to use Pythagoras' theorem pretty quickly now to work out the value of B. So we substitute in 2 and 1, 2 for our hypotenuse. We end up with 4 equals 1 plus B squared. B squared will equal 3, therefore the square root of B is root 3. So we're going to represent that B as root 3. Now we've got this triangle and now we can use trigonometry to work out the angle of theta. So we'll start up in that top corner there. Okay, so we're going to label our triangle opposite, adjacent and hypotenuse, and then we'll use our trig ratios. So sine theta will be the opposite of root 3 and that will be over the hypotenuse of 2. So our exact value for the sine here for theta is going to be root 2. So root 3 on 2. Now we're going to use our calculator and that will be sine inverse of sine on the calculator. So you use your shift button with the sine button there. And theta will be exactly 60 degrees. So we've just used this triangle now to derive the exact value. So our conclusion is that sine 60 is root 3 on 2. So we can pop that into our table. Okay, now we know that is for sine. What about cosine? Well, cosine is going to be the adjacent side over the hypotenuse. So the cosine of 60, because we know that angle now is 60 degrees, is going to be exactly a half. And we can pop that in our table. And that leaves us with the tangent, which is opposite over adjacent, which will be root 3 on 1, which we would simply represent as root 3. So we know now that the tan of 60 is root 3. So you can see if you use this triangle in an exam, 2 on the hypotenuse, one side with a 1, you can quickly work out using Pythagoras' theorem what that opposite side is, and then If you know that angle in the top corner is a 60, or you could simply start with a 60, 30, 90 triangle, and then you can work out your ratios that way. Okay, so we can pop that into our table. Now, we know in this triangle that the sum of angles of a triangle is 180 degrees. That means our remaining angle is 30 degrees. Now we can use that 30 degrees to find all of our ratios, starting again with sine. So we're going to relabel our triangle now, because now we're looking at 30 degrees, so we've got a different opposite and a different adjacent, but the hypotenuse is still the same. So now sine 30 is going to be opposite over hypotenuse, which is a half. The cosine of 30 will be root 3 on 2, and the tan of 30 will be 1 over root 3. We'll pop those in our table now. Now you'll notice some interesting things. Firstly, the sine of 30 is the same as the cosine of 60. So they switch around, and you can see the same thing happens in reverse. The cosine of 30 is the same as the cosine of 60. That's an important thing to remember, that they're the opposites of one another. And then you'll notice that tan of 30 is very similar to the tan of 60. In fact, one is the inverse of the other. So one is root 3, that's the tan 60, and the other one is 1 divided by root 3. So there's some interesting patterns that form there. And this is going to be important later on when we graph it, because you'll notice when we graph it that we get some interesting patterns coming out of this, but that's in a future video. Okay, let's look now at the 45-degree angle and see if we can derive those. We're going to consider an isosceles right angle triangle this time. That means we've got a right angle and both of our small sides are equal in size. So we're going to give those each a unit of 1. So that's an easy thing to remember there. Both of those are 1. We just need to find the hypotenuse once again. And we remember that because 90 degrees is our angle in that isosceles triangle, that leaves 90 degrees left over from the sum of angles in a triangle. So that means they're 45 degrees each. And now we can start using that triangle to work out some ratios. But firstly, let's find the length of the hypotenuse using Pythagoras' theorem. So once again, we're going to substitute into the formula. So 1 squared plus 1 squared gives us 2. And therefore, C is going to be root 2. So our hypotenuse is the square root of 2. We'll leave that as a surd, an exact value. Okay, now we can find our ratios. So either of those, 45, because our opposite is 1, and our hypotenuse is root 2. So the sine of 45 will be 1 over root 2. Cosine of 45 will be the exact same, because the opposite and the adjacent are equal in value. The tangent of 45 is going to be opposite over adjacent, 1 over 1, which is 1. So let's pop those into our table here, and now we can see that's filled out. So we can see that the sine of 45 and the cosine of 45 are identical. This will make a lot more sense too once we see it graphically in those future videos I'm promising you. Okay, let's do a quick worked example. We're going to state our exact values without using a calculator for sine 30 divided by the cosine of 30. Now this is the type of question you could get in a year 10 exam potentially in extension classes, where you're working with those exact values and you're also demonstrating your algebraic and your fraction working skills. So firstly, what we need to recognize here is from our table that the sine of 30 is a half, and that the cosine of 30 is root 3 on 2, and we're dividing one by the other. So our first step is going to be to flip that second fraction and change that divide symbol to multiply. So knowing your fraction division rules is really important. So let's change that over now. Okay, and our next step is to multiply across the top of the fractions. 1 times 2 gives 2. Multiply across the bottom, we get 2 times root 3 gives 2 root 3. Now our second step now is to rationalize the denominator. You could technically leave it as 2 over 2 root 3. However, it's always important that we rationalize our denominator when we're doing these kinds of problems for year 10 extension. So we're actually going to multiply our fraction by root 3 over root 3, which is basically the form of 1. So we're not really changing the fraction, we're just rationalizing that denominator, which is going to give us 2 root 3 divided by 2 times root 3 times root 3. Root 3 times root 3 is just 3, so that's going to become 6. And our final step here is now to simplify the fraction of 2/6 into 1/3. So it becomes root 3 over 3. In fact, you could have probably at this stage here simplified your fraction to 1 over root 3. but it's easier just to follow that through to the end. Okay, well, hopefully this video was helpful to you. And if it was, why not tell someone? Share it with your teacher, share it with a friend or a sibling. You could like and subscribe to the channel and hit that notifications button so you'll always know when we've got new videos available to watch. In fact, in our upcoming videos, as I mentioned earlier, we're going to look at graphing the sine, cosine, and tangent functions. We're going to look at the unit circle. We're also going to have a memory tool to memorize that table really quickly, because you don't want to have to draw a triangle in the exam every single time and work it out manually. It is helpful to know how to do that in case you can't remember the memory tool, but I'll show you a memory tool in our next video. Also, if you've got any questions, you can contact me at mcclutchymass@yahoo.com or direct message me on Facebook and Instagram. Do follow us there on social media. It's a great way to stay in touch. And thank you to all of our ongoing subscribers here at the channel. We really appreciate your support. Well, I'm Natalie McClutchy. You've been watching McClutchy Maths. Have a wonderful day.